We'll now begin section 3.6 and discuss combining functions. We begin with a definition for addition, subtraction, multiplication, and division of functions. Let f and g be two functions. The sum, f plus g, the difference, f minus g, the product, f times g, and the quotient, f divided by g, are four new functions defined as follows. The sum f plus g is equal to f of x plus g of x. The difference f minus g is equal to f of x minus g of x. The product fg is equal to f of x times g of x. And finally, the quotient f divided by g of x is equal to f of x divided by g of x, assuming that g of x is not equal to 0, because we know that we cannot have a denominator in a fraction equal to 0. Let's begin with an example. Given that f of negative 2 is equal to 5, and g of negative 2 is equal to negative 3, the problem asks us to find f minus g of negative 2 and also f divided by g of negative 2. So let's begin with our subtraction. Now, remember on our definition, and I'm going to flip back to show you, for our subtraction, our rule says that we can look at the f of x minus the g of x separately. And so in our case, we're not dealing with an x, but we're dealing with a negative 2. So we're asked to find f of g of negative 2, which would be f of negative 2 minus g of negative 2. So let's take that back to our example. So f of negative 2 minus g of negative 2. And both of those are defined for us. We know that f of negative 2 is equal to 5. And we know that g of negative 2 is equal to negative 3. And we are subtracting these, which means we're really looking at 5 plus a 3, which would give me 8. The other part of this problem asks us to do the quotient, f divided by g of negative 2. And again, if we look back at our definition, if we're asked to find f of g of negative 2, then we know that we can do f of negative 2 and g of negative 2, and then divide the results. And again, we know what each part of this is. F of negative 2 is 5, so 5 goes on the top. G of negative 2 is negative 3, and so negative 3 goes on the bottom. And so the answer would be negative 5/3. Now we're going to work a problem that has an x instead of a number. So our functions are f of x is equal to 4x squared minus 1, and g of x is equal to the square root of x. And the first thing that we want to find is f plus g of x. And we know that our definition says that this is equal to f of x plus g of x. So let's go ahead and plug in our functions. So we know that f of x is equal to 4x squared minus 1. And we know that g of x is equal to the square root of x. And so we really are pretty much done at this point. We might order our terms in descending order according to exponents, but otherwise we are finished. So our final answer will be 4x squared plus the square root of x minus 1. We're also asked to find f times g of x. And again, our definition says this is f of x times g of x. So let's plug in what we know. We know that f of x is 4x squared minus 1. And g of x is the square root of x. Now to simplify, we need to distribute this square root of x to both of those terms. So I'm going to come up here for a minute, and I am going to rewrite that square root of x with an exponent. Do we remember what exponent is equivalent to a square root? So we know that it's a 1/2 power, and so we're going to multiply that times each of these terms. So multiplying it times 4x squared, remember if your bases are alike, you're going to be adding your exponents. So 2 plus 1/2 gives you 2.5 or 5/2 on that x. And then when you multiply it by the -1, you're just going to have negative x to the 1/2 power. And so our final answer for the product will be 4x to the 5/2 minus x to the 1/2. Now, they are going to ask us to discuss the domain of these two functions that we just found. So let's go back and look at that, and then we're going to come back to this slide in just a second. So our function f I'm going to leave our final answers, but make ourselves a little bit of space here. Okay, so this is our f plus g function. This is our f times g function. All right, so when we look at our domain, let's look at each of the individual functions separately. So let's talk first about the domain of f. Now, the domain of f is a quadratic function. So if you're thinking about what x values you can plug into that function and still be able to solve for y, you will realize that that will be actually anything. And if you think about even the graph of that quadratic function, we know that it graphs a parabola. And I don't really know exactly where it is without working it out. But you know, let's just suppose it's here. And if it's here, then the x values that are possible are all of them, because as this continues to get higher, it also moves over to the right, and as this continues to get higher, it moves over to the left. And so the domain is going to be everything from negative infinity to positive infinity, or you could have said all real numbers there. All right, so what about for our function g? It is the square root function, which we do know looks like this. And so when we look at that, we know that we can only take the square root of positive numbers, which is shown on the graph, or 0. You can't take the square root of 0. And so your domain would start with 0. It would have a bracket to say that it includes 0 as a possibility. And then it would include all your positive numbers, so going up to infinity. Now, when you do an addition or a multiplication, what you need to do is you need to look at your individual domains, and then you need to look at where those domains intersect. And that intersection is going to be the domain of your new functions. So if I'm asked to find the domain of f plus g of x, I am going to say that it is from 0 to infinity. And I'm going to do the same thing over here. So the domain of fg of x is going to be that same set from 0 to infinity. And again, because you're looking at the intersection. So I'm trying to think how to show you this. The domain of f, if you think about your number line, your f function includes everything on your number line. And your g function starts at 0 and includes everything that's positive. And you only want, for these two new functions, you only want the x values that are common to both. So where the red and the blue sort of intersect is what you want to write down for your domain. So starting at 0 and going all the way to positive infinity. And so this slide just basically goes through that. It says that we need to find first the domains of the individual functions f and g, which we did. And then since the domains of the two functions combined is the intersection of the individual domains, they both have this domain from 0 to infinity. Our next example asks us, it says, given the graphs of f and g below, determine the domain of f plus g and f divided by g, and evaluate f plus g of 1 and f divided by g of 1. All right, so let's look first at the domain for these two functions. So let's look at the domain of f, which is the green function. And again, this is a quadratic equation graphing a parabola. So we know that the domain is going to run from negative infinity to positive infinity. As each side of this parabola goes up higher and higher, it also will shift over further to the right and to the left. We'll have the same situation occurring for the domain of the purple function. So the domain of g, also a quadratic function. And so also as the legs of that parabola go further down, they also go further out to both sides. And so our domain for function g is going to be negative to positive infinity as well. And so remember that you're simply, to find the domain of your sum or your quotient, you're going to look at the intersection of the two individual domains. And since both of them are negative to positive infinity, they'll intersect at every point. All right, so the domain of f plus g is negative to positive infinity. The domain of f divided by g is also going to be negative to positive infinity. The only exception on the quotient that you need to be careful about is you need to be sure that the g is not going to end up being 0, because remember that when you're dealing with a fraction, you cannot have a 0 in the denominator of that fraction. So we'll have to come back and we'll have to look at that in just a second to be sure that we're not going to have a 0 coming out of that. All right, so let's look at our graph and see, is there a place where the function g equals 0? And we actually have two places where that's happening. We have this point right here and also this point right here. So along the x-axis, if your x value is 2, that's going to be a problem. And if your x value is negative 2, that's also going to be a problem, because that's going to cause the g to be 0, which is going to cause the fraction to be undefined. So let's come back and let's see if we can adjust this just a little bit and get a little bit more accurate domain. So if we start this thing at negative infinity, we are good until we get to negative 2. But negative 2 needs to be excluded. So I'm going to stop my domain at negative 2. And notice I'm using a parenthesis because I don't actually want to include the negative 2. I'm going to sort of jump over the negative 2 and pick up on the other side of it and continue along my number line until I get to positive 2, which is my other problem point. And then I'm going to stop there and I'm going to skip over 2. Come back on the other side and then continue until I reach positive infinity. And so we're going to put U's in between these things to indicate union of those sets. And so as I said, you do have to be careful with your quotient that you want to exclude anything that would cause the denominator to equal 0. All right, so the last thing that we need to do on this problem, we've got our domains done. We need to find f plus g of 1, and we need to find f divided by g of 1. All right, so let's do f plus g of 1 first. Remember that our definition says we can break it up and do f of 1 plus g of 1. So let's go to our graph and let's look at what happens in the f function, so the green function, when the x value is 1. So if the x value is 1, it's happening right there. The graph is up at 1, so it has a height of 1 right there. All right, now let's look at the g function at 1. So the g function at 1 is up here, which is at 1, 2, 3. So f plus g of 1 would equal 4. All right, and then we're going to do the same thing for the quotient. Again, we're going to do f of 1 divided by g of 1. And we've already found these now, so we know that f of 1 was 1 and g of 1 was 3. And so f divided by g would be 1/3.